the vast, swirling vortex of the Eastern Front, a crucible of ice and blood. Deep within a fortified bunker, the air is thick with the smell of stale cigarette smoke, sweat, and a growing sense of frustration. Colonel Erich Bauer, a veteran signals officer of the Wehrmacht, leans over a map, his brow furrowed, his eyes scanning the flickering readouts of a captured Soviet radio set. Around him, technicians in field-gray uniforms frantically tune dials, trying to make sense of the cacophony of the airwaves. Their mission? To decipher the enemy's whispers, to understand the invisible threads that bind their forces. But it is not the Soviets who truly confound them. It is the Americans. The reports coming from the Western Front, from North Africa, from the vast Atlantic, are increasingly bizarre, almost unbelievable. German U-boat commanders, masters of the silent hunt, report entire convoys moving with uncanny coordination, their ships shifting formations, their escorts reacting with preternatural speed to unseen threats. Luftwaffe pilots, confident in their superior aircraft and training, are ambushed by unseen American fighters, their formations shattered by coordinated attacks that seem to materialize from nowhere. The problem, Bauer realizes, is not what they can hear, it's what they cannot. American radio traffic, when intercepted, is often a garbled mess of static and indecipherable chatter. Yet, somehow, the Americans never seem to lose contact. Their units, from the smallest patrol to the largest bomber formation, maintain an unbroken link, a constant, real-time conversation that seems immune to the usual atmospheric interference, enemy jamming, and the vast distances of modern warfare. For the Germans, communication is a fragile thing. Their state-of-the-art Enigma machine may encrypt their strategic orders, but tactical battlefield communication is often a chaotic affair of unreliable field phones, signal flags, and runners. Their radios, powerful as they are susceptible to static, to the vagaries of the ionosphere, and to the growing sophistication of Allied jamming techniques. A unit cut off from its command, blinded and deafened, is a unit doomed. They understand this intimately because they experience it daily. But the Americans, their voices, distorted and crackling, are always there. It is an enigma wrapped in static, a tactical ghost in the machine. As the war intensifies and the sheer scale of American deployment grows, this unbroken link becomes more than just a curiosity. It becomes a critical strategic advantage, enabling a level of battlefield coordination the Germans can only dream of. Colonel Bauer, tracing lines on his map, feels a cold dread. They are not just fighting an enemy of men and machines. They are fighting an enemy whose very conversations are a weapon, whose constant connection allows them to move with a speed and precision that defies conventional warfare. The question gnawing at him is simple: how? And the answer, when it finally comes, will reveal a hidden chapter in the history of radio, a story of unsung heroes, unlikely innovations, and a secret weapon woven from the very fabric of the air itself. To truly appreciate the American radio advantage, we must first understand the fundamental challenges of radio communication in the 1,940 seconds. It wasn't the seamless, crystal-clear experience we know today. It was a battle against physics itself. The medium was the electromagnetic spectrum, a vast ocean of invisible waves. But the tools to harness it were still rudimentary, and the atmosphere was a fickle, unpredictable beast. Imagine a single voice trying to shout across a roaring hurricane. That was often the reality for a radio operator. Signals, particularly in the high-frequency HF band, then primarily used for long-range communication, were dependent on bouncing off the ionosphere, a layer of charged particles in the Earth's upper atmosphere. This made long-distance communication possible, but it also made it inherently unstable. Solar flares, geomagnetic storms, even the time of day and the changing seasons could dramatically alter the ionosphere, causing signals to fade, distort, or disappear entirely. It was like playing billiards on a table whose dimensions constantly shifted. Then there was static, electrical storms, interference from other radio transmissions, and the sheer electrical noise of a modern battlefield created a constant, maddening hiss and crackle that could render even strong signals unintelligible. For German radio operators, listening intently for crucial commands or intelligence, it was a constant struggle, a fight to discern meaning from chaos. Their radios, while technically advanced, often operated on relatively narrow frequency bands, making them susceptible to both natural interference and deliberate jamming. If an enemy transmitted a powerful signal on the same frequency, the German transmission would be drowned out, effectively cutting off communication. The German philosophy of radio communication, while employing excellent equipment, tended towards a more centralized and often less redundant system. Orders would be transmitted, acknowledged, and then units would operate, often in radio silence, until new orders were required. This preserved secrecy but sacrificed flexibility and real-time coordination. If that critical link was severed, the entire command chain could seize up. Their transmitters were powerful, their receivers sensitive, but their doctrine often assumed a static environment that simply didn't exist in the dynamic maelstrom of modern warfare. The battlefield was a swirling, dynamic environment where units were constantly moving, objectives were changing, and the need for immediate, responsive communication was paramount. The limitations of their radio technology, combined with a doctrinal rigidity, often left German forces fighting blind and deaf, especially when faced with an enemy that seemed to possess an almost magical ability to cut through the static. The unseen battlefield of the airwaves was rapidly becoming as critical as the ground itself, and the Germans were struggling to find their footing in this new, invisible domain. When the first captured American radio sets began to arrive at German technical intelligence facilities, there was an initial sense of dismissive confidence, almost arrogance. The technicians, meticulously cataloging the equipment, found it to be, in many respects, seemingly inferior to their own. Their German radios, built to exquisite standards of precision engineering, often boasted more stable oscillators, more powerful transmitters, and more sensitive receivers in certain frequency bands. Their components were flawlessly crafted, their chassis robust. The American gear, by contrast, often appeared utilitarian, mass-produced, sometimes with visible shortcuts in construction, and lacking the fine-tuned elegance of their German counterparts. The German technicians would scoff, noting the slightly less robust casing, the seemingly less sophisticated internal components. They concluded, with a touch of nationalistic pride, that this was simply another example of American mass production over quality. They believed they held the technical advantage. They tested the captured equipment, expecting to find glaring deficiencies in range, clarity, and resistance to interference. What they found, however, was a paradox. While individual specifications might not always surpass German equipment, the American radios consistently performed. They didn't lose connection as easily. They cut through static with surprising resilience. They seemed to maintain their link even when German sets would falter. This was a mystery that defied their initial, confident assessment. It wasn't about raw power or individual component superiority. There was something else at play, something subtle, yet profoundly effective, that they were missing. The perceived inferiority masked a deeper, more fundamental difference in philosophy. American engineers, under immense pressure to equip a vast army quickly, had focused on practicality, robustness, and, most critically, a different approach to the radio spectrum itself. They understood that in a chaotic, dynamic combat environment, raw power and narrowband precision could be a liability. They needed flexibility, redundancy, and a way to mitigate the inherent instabilities of radio propagation. The solution wasn't necessarily to build a more powerful transmitter on a single frequency, but to find a way to make communication survive the unpredictable nature of the battlefield. The answer wasn't in the strength of a single signal, but in the intelligent management of the entire, sprawling tapestry of electromagnetic waves. And that, the Germans were slowly beginning to realize, was a much harder problem to solve. The first major realization for the German technicians, as they delved deeper into the captured American radio gear, was the widespread adoption of frequency modulation, FM technology. This was a critical divergence from their own approach, which heavily relied on amplitude modulation. To understand the genius of FM for battlefield communication, imagine sound waves as a ship on the ocean. In AM, the amplitude height of the wave carries the information. If the ocean gets rough with other waves, static or interference, the ship's message gets lost as its height is distorted. German AM radios, while powerful, were constantly battling this noise. A strong static burst or an enemy jamming signal on the same frequency would simply overpower the message, making it unintelligible. FM, by contrast, encodes information by varying the frequency of the wave, not its amplitude. The height of the wave remains constant. This subtle difference was revolutionary. Because the information wasn't carried in, the amplitude FM signals were far more resistant to static and interference. As long as the FM signal was stronger than the background noise by a certain threshold, the receiver could effectively ignore the amplitude variations caused by static and extract the clear, undistorted message. It was like filtering out all the irrelevant shouts in a crowded room to hear a single, consistent whisper. This capture effect of FM was a game changer for tactical radios. While a strong AM signal might still be garbled by static, a relatively weaker FM signal could emerge clear and crisp. This meant American tank commanders, infantry platoons, and forward observers could maintain reliable voice communication even under heavy shelling, through electrical storms, and in the face of enemy jamming that would render German AM sets useless. The sound of their radios wasn't always perfectly clear. It was often distorted by the inherent nature of FM's low fidelity, but it was there. The message got through. The Germans, while aware of FM technology, had largely dismissed it for military applications due to its perceived shorter range and the need for wider bandwidth. They had focused on improving AM systems, believing that raw power and precision would win the day. Now, they were confronting the stark reality. The Americans had traded pristine audio quality for battlefield resilience, and the payoff was an unbroken tactical link that allowed their forces to move and react with devastating cohesion. It wasn't about shouting louder, it was about whispering clearly through the storm. Beyond the technical marvel of FM, the German technicians began to unravel another equally crucial aspect of American radio superiority: the philosophy of design and production. This wasn't about singular brilliance, but about systematic effectiveness. While their own military radios were often engineering masterpieces, finely tuned and meticulously crafted, they were also complex, expensive, and slow to produce. Each unit was almost an artisanal creation. American military radio gear, by contrast, embodied the very spirit of mass production, but with an intelligent focus on combat realities. Simplicity was paramount. The designs minimized the number of critical components, making them easier and faster to assemble. Durability was non-negotiable. These radios weren't designed for a pristine laboratory. They were designed to be dropped from trucks, drenched in rain, pounded by artillery concussions, and still function. Components were often over-engineered for robustness rather than finely tuned for peak theoretical performance. The production lines were vast, turning out radios by the tens of thousands. This meant that every tank, every jeep, every infantry company could be equipped with multiple sets, creating redundancy. If one radio failed or was destroyed, another was readily available. This sheer volume contrasted sharply with the more limited production runs of specialized German equipment, which, while superb, often struggled to meet the demands of a sprawling conflict. Furthermore, the American approach extended to maintenance. The radios were designed for easy field repair. Modular components meant a damaged part could be swapped out quickly, even by a relatively unskilled technician. This reduced downtime and kept more units on air where they were needed most. The German technicians, accustomed to intricate repairs requiring specialized tools and highly trained personnel, were struck by this pragmatic approach. It wasn't just about building the best possible radio. It was about building the most useful radio, a device that could be deployed en masse, survive the brutal conditions of combat, and be kept operational with minimal fuss. This underlying philosophy, driven by the pressures of total war, ensured that the inferior American gear, in aggregate, created an unbroken web of communication that German forces simply could not match. As the German technicians moved beyond the internal workings of the captured radios, their attention turned to a seemingly mundane yet profoundly important component: the antenna. This, too, told a silent story of American battlefield pragmatism and a deep understanding of radio physics. While German tactical radios often utilized dipole or collapsible rod antennas, which required careful setup and were vulnerable to damage, the Americans had widely adopted the flexible whip antenna and the concept of the ground plane. The whip antenna, a long, slender, flexible rod, typically mounted vertically on vehicles, was robust and simple. It could bend without breaking, resisting the abuses of off-road movement, low-hanging branches, and even minor shell fragments. Its omnidirectional pattern was ideal for tactical communications, where the exact direction of the receiving unit was constantly changing. More importantly, its design worked in conjunction with the vehicle's metal chassis as a ground plane. In radio theory, an antenna works by creating an electromagnetic field. To do this efficiently, it needs a counterpoise, or ground. For a whip antenna, the large metal body of a tank or jeep acted as this critical ground plane, effectively becoming part of the antenna system. This design maximized the antenna's efficiency, allowing for surprisingly strong and consistent signals, even from relatively low-power transmitters. German antennas often relied on more complex counterpoise arrangements or extended ground wires, which were time-consuming to deploy, susceptible to damage, and less effective on the move. The simplicity of the American antenna design meant faster deployment, greater mobility, and enhanced resilience. A tank commander could quickly set up his radio and be on the move, maintaining communication without the need for intricate antenna adjustments. This allowed for the rapid, dynamic maneuvers that characterized American armored advances, where constant communication between tanks and with supporting infantry was absolutely vital. The German technicians recognized this. It wasn't a flashy innovation, but a fundamental, practical advantage. Their own antennas, while sometimes offering theoretical benefits in static positions, often became liabilities in the fluid, brutal chaos of the battlefield. The American whip antenna, deceptively simple, was a testament to a design philosophy that prioritized function over form and battlefield utility over laboratory perfection. While true frequency hopping spread-spectrum technology, as we know it today, was still decades away from widespread military implementation, the American approach to radio communication incorporated key precursors and principles that made their systems remarkably resilient to enemy jamming. German technicians, as they examined the operational doctrines, realized that the Americans weren't just relying on FM. They were employing clever strategies across the frequency spectrum. Firstly, the Americans utilized a much wider array of operating frequencies, and their doctrine encouraged rapid switching between them. German units often had designated frequencies for specific operations, making them predictable targets for jamming. American units, however, possessed the flexibility to quickly shift to alternative channels if they encountered interference. This wasn't automated hopping, but rather a disciplined, manual process that baffled German jamming attempts. When a German operator began jamming a specific frequency, the American unit would simply move to a prearranged alternate, leaving the jammer broadcasting into an empty channel. Secondly, American tactical radios often had a relatively robust transmit power for their class, particularly for FM signals. This, combined with the FM capture effect, meant that an American signal could often muscle through a jamming attempt if the jammer wasn't significantly more powerful or closer. The jammer would create noise, but the FM receiver could still extract the intended voice, albeit with some distortion. For the Germans, who often relied on brute force jamming to silence enemy communications, this resilience was a constant source of frustration. Their jamming efforts, while effective against Allied AM transmissions, were far less successful against the more robust FM signals. Thirdly, the American concept of network redundancy was crucial. With so many radios in the field, and a doctrine emphasizing constant contact, if one unit's primary radio link was severed, another nearby unit could often act as a relay, passing the message along. This web-like structure provided multiple pathways for communication, making it far harder for the Germans to completely isolate an entire American force. The German technicians realized that they weren't just fighting individual radio sets, they were fighting an entire interconnected communication ecosystem. This flexible, redundant, and frequency-agile approach meant that while individual messages might occasionally be lost or delayed, the overall flow of American command and control remained remarkably unbroken, a testament to a strategic understanding of the radio battlefield that eluded their German counterparts. Beyond the technical hardware, the German technicians, through their analysis of captured documents and interrogations of captured American radio operators, began to grasp the profound impact of American doctrine and training. This was the invisible force multiplying the effectiveness of their seemingly inferior equipment. American military doctrine placed an unprecedented emphasis on fluid, decentralized command and control, particularly at the tactical level. Commanders were expected to communicate constantly with their subordinate units, and units were expected to report their status and needs in real time. This fostered a culture of continuous communication, where being on the net was paramount. German doctrine, while highly effective in structured set-piece battles, often relied on more rigid command structures and intermittent reporting, leading to delays and a lack of situational awareness when circumstances changed rapidly. The training of American radio operators also stood out. They were not just taught to operate their equipment, they were taught the art of radio communication under combat stress. They learned to speak clearly, concisely, and to use standardized brevity codes. They were drilled in rapid frequency changes, in understanding propagation conditions, and in troubleshooting under fire. They understood the importance of their role as the ears and voice of their unit, and they were empowered to make decisions to maintain that link. This emphasis on the human element, on training individuals to maximize the utility of their equipment, was a critical differentiator. A well-trained operator could often overcome the limitations of their gear, while a poorly trained one could render even the most advanced radio useless. The Germans, with their more limited pool of highly specialized radio personnel, often struggled to match the sheer volume and widespread competence of American operators. They relied more on the inherent quality of their equipment to compensate for gaps in training or doctrine. The synergy between robust, mass-produced FM equipment and a flexible, communication-centric doctrine, backed by comprehensive training, created a formidable, resilient network. The German technicians realized that the American advantage wasn't just a technical one, it was a systemic one, a reflection of an entire military philosophy adapted to the dynamic, unforgiving realities of modern warfare. It was a complete ecosystem of communication, where every component, human and mechanical, worked together to maintain the unbroken link. As the war progressed and the German military faced the full might of the Allied advance, particularly in Western Europe, the true strategic impact of America's communication advantage became terrifyingly clear. It wasn't just about individual units staying in contact. It was about unleashing a level of combined arms coordination that the Germans simply could not counter. Imagine a German panzer division moving swiftly to reinforce a crumbling front line. They expect to encounter fragmented, uncoordinated, Allied resistance. Instead, they are met with a perfectly orchestrated storm. American artillery, guided by forward observers speaking directly to battery commanders over FM radio, lays down a devastating barrage with pinpoint accuracy, close air support, with fighter bombers receiving real-time targeting information from ground units, appears overhead almost instantly, turning German tanks into flaming wrecks. This seamless, real-time coordination was revolutionary. American infantry could call in tank support or artillery fire with unprecedented speed. Tank units could communicate directly with each other, forming responsive battle groups. Air forces could be vectored to specific, rapidly evolving targets on the ground, turning the tide of local engagements. This meant that German counterattacks, even when launched with skill and ferocity, were often blunted and then destroyed by a rapidly coalescing Allied response. The ability to react in minutes, not hours, to changing battlefield conditions was a decisive factor. For the German commanders, this was a catastrophe. They often found their units isolated, unable to communicate with each other, their movements tracked and reported by an invisible network of American radios. Their own attempts to coordinate complex maneuvers often faltered due to communication breakdowns, jamming, or the sheer difficulty of maintaining contact across a vast, chaotic front. The advantage that their U-boat commanders had noted earlier in the war, the uncanny coordination of Allied convoys, was now being applied with devastating effect on land and in the air. The unbroken link wasn't just a comfort, it was a weapon, systematically dismantling the German war machine piece by agonizing piece. The war eventually ended, and the German technicians, no longer enemies, but curious analysts, continued their studies of Allied technology. The lessons learned from those captured American radios, once dismissed as inferior, became foundational to post-war military communication development. The widespread adoption of FM for tactical battlefield radios became a global standard. The principles of redundancy, robust design, and comprehensive operator training were integrated into military doctrines worldwide. The legacy of unbroken contact wasn't just about winning World War II, it shaped the very nature of modern warfare. From the Korean War to Vietnam, from the Cold War to today's conflicts, the ability for tactical units to communicate reliably in real time has remained paramount. The concepts pioneered by American engineers and operators, driven by the desperate needs of a global conflict, evolved into the secure, digital, satellite-linked communication systems that define contemporary military operations. The story of how German technicians initially underestimated American radio gear, only to realize its profound strategic advantage, serves as a powerful testament to the often hidden battle for technological and doctrinal supremacy in warfare. It highlights that innovation isn't always about the flashiest invention or the most powerful weapon. Sometimes it's about the underlying philosophy, the systematic approach, and the commitment to ensuring that even in the greatest chaos, the lines of communication remain open. The ability to talk, to coordinate, to share information instantly. This seemingly simple act became a force multiplier, a critical weapon that allowed millions of individual soldiers to act as a unified, responsive organism. It was the whisper that cut through the roar of battle, the thread that held the Allied war effort together, and ultimately the unbroken link that led to victory. The lessons learned in those German bunkers, as they struggled to understand the silence that wasn't silent, still echo in the sophisticated communication networks that define military power today.